Zbigniew. I work at Wire. Wire is a messenger application. And the nice part about it is that most of it, or a big part of Wire is written in Scala. So yeah, I will, but the thing that I will be talking about is not really used at Wire much. It's my own project. I use it for my own personal project. This talk will not be about Scala language itself. It will not be about using Scala on Android, and not about application design or architecture. It will be using Scala so it's possible, so I will show you that we can use Scala, but I will not show how. Yeah, but this will be only about creating reactive UI, using Scala as a technique, and some techniques that are actually enabled by Scala. In this specific example is the signals. So I will just start with introducing what signal is, what's my implementation of signal, and then we will go with case study of using the signals to implement UI. Yeah, in general, signal is just a value that changes over time. The idea is for functional reactive programming, but it's changed quite a lot for Android-specific tasks. When I started using that, when I read a paper from Scala author Martin Warewski, paper title is Deprecating Observable Pattern. So this is, signal is pretty much an observable. It has a way to change the value, and it has a way to subscribe for changes. That's pretty much observable in Java. But that's not all. Signals are composable. We can create one signal by combining to others. In this sense, signals are very much like cells in a spreadsheet. You just define one cell as a function of using inputs from other cells, and then whenever something changes, this change is propagated. That's the idea for creating applications with signals. Just build a huge graph of dependencies, and any change is just propagated through the graph. For many people, signal could look very much like event stream. We can actually convert signal to an event stream. In this example, the blue line is a signal, and the red dots are event stream, which corresponds to the signal. It may seem like the same thing, but it's not, because there are some specific properties in signals which make it different and which make it useful for other stuff. Main thing is that in signal we actually care about current state. We actually care about current state in the whole graph of dependencies. We don't really care about event changes. We don't care about individual changes of values in signals. We care what's the current state, and that the state actually propagates. Yeah, like I said, there's other properties. Some of them go back to the definition of signal, and some are introduced by my implementation. Yeah, let's go through it. First is that signal can be empty. This is very useful when we load something from database or from network. Initially, signals will be empty, but then once we load the data, signal will get the value and will notify all its subscribers. Signal can also become empty at some point. The thing is, whenever it becomes empty, it doesn't really notify its subscribers about it. It will just stop propagating changes. But then at some point it will get new value and notify about it. The idea is that these intermediate states when the signal is empty are just intermediate states. It's not, our logic should not rely on that. This usually means that we are loading new data. And that's how signals are used with this empty state. If we actually want to, in logic, have some value which is not there, then just our signal should have an option inside, which just tells us there is a value or not. And very important property is that our signals can skip intermediate changes. When you subscribe to to a signal, it's possible that this signal will not notify you on every change. There could be some outlying change which comes back to the previous value, and then you are not notified about it. Or then there could be multiple changes to the signal, and you are only notified about the final state. This may seem like very unreliable, because signal has a right to do that. That's our contract. It seems unreliable, but actually in most cases, in the cases that I use signals, this is very nice property. Because I use signals to bind a state to a view. So there is no point in displaying some intermediate change. It will be just flickering on a screen. We actually care about the final state, and we only want to show the UI a final state. Also, signals guarantee that the final state will be there eventually. So it may not notify about intermediate changes, but at some point you will get the first value. And that's what user cares. User wants to see UI at some point. And signals are lazy. Lazy meaning that we don't process signals if there is nobody listening to them. You can have huge graph of dependencies, but only a small part of it will be computed at a time. Listening to signal is not just that there is a subscriber, but also that the subscriber is active. Active in a sense of components in the UI. I mean, we can have some fragment which is not added to an activity, so this is not active and we don't want to update it. And very important property that signals guarantee that your graph of dependencies will eventually be consistent. There could be many intermediate changes. Some values may seem wrong because all changes are propagated asynchronously. So it might happen that depending from the order, some signal will get weird intermediate values. But at the end, the whole graph should be consistent. There is one thing which I call it event context. And this corresponds to the lifecycle of a component in Android. So we have global event context, we have service context, activity fragment view. This is something that actually tracks the lifecycle, and signals obey to it. Every time you subscribe to a signal, you have some implicit event context. And when this context gets paused, all signals, all subscription in this context will be paused. This way, we have automatic pausing whenever your view goes out of screen. And also, we have automatic cleanup. You don't need to add subscribe in your onDestroy method. Everything will be cleaned up and unsubscribed and not used. So you don't need to care, like, right now onDestroy, you need to tear down everything. And we have thread-safe API. Thread-safe is a goal. There are some bugs in there. I've already rewritten this stuff 3 times because thread-safe is not so easy. And we also don't want to lock. So most of the time this is non-locking and thread-safe. That's the idea. So like when we set a value on a signal, we use this exclamation mark. This is to signify that it's not really setting a value, it's more like sending a message to a signal, because we are sending a message through our graph. That's why I use exclamation mark there. We can also change the value in a signal in atomic way. For that we have mutate operation. We just will increment the value of 10. And we can get current value from a signal. Current value returns option because the signal could be empty. Then the option will be none. And when we want to subscribe on a signal, we just do something like that. In this place, we also specify that this subscription should be invoked only on the UI thread. We can omit the on part and just have block there, which will execute every time the signal value changes. But we can also specify on which thread this has to be done. This is very useful for UI work because we can only access UI elements from UI thread. And we can compose signals. There are many operators. Main ones are map and flat map. They work like in Rx Java. So when you have a signal with some object inside and you want to have a signal with just a field from this object, you do map like that. And then you can use the resulting signal whenever you will need it. The same with flat map. You have the signal with some value, you map it with a method which returns another signal, and you get composed signal. Whenever the source value changes or the signal that was returned from a service changes, your resulting signal will be changed. Yeah, that's in general about signals. So we can try to implement something with them. Our plan, well, our task is to design a small audio player. This will be just one control for the audio player. And we got a design for it. We will assume that our layout is already done in resources. We have all other resources that we need. And we need to just implement the logic under this control. We need to make sure that the current state of playback is displayed. We need to display what's the current song in an album, what's the, if we are playing or not, display what's the position of the playback, what's the length of the song, and of course we need to handle buttons. We also need to take care about edge cases. What happens if there is no song selected? What happens if info for the album is not yet loaded from network? In this case, the only info that we need from an album is the count of songs in there, but there could be something more. We will assume that we don't really need to do it in UI. We won't be showing some loading spinner here. This will be the dependent requirement of UI somewhere else to show this control only when everything is there, but we shouldn't crash when there is no song. So we don't care what we display, but we cannot crash. Of course, to do that, we need to have some service to give us all the information and to control the playback. In our case, this will be just a simple interface which has all the information that we need. Current song is the signal with ID of currently played song, or actually currently selected song. Then there we have signal with playback state and playback position. Playback position in this case is actually a function which returns the signal, because we assume that our service can actually keep playback position for every song. This way we can switch between songs and keep the playback position. And then we have methods to get information about current song and current album, and methods to control the playback. We get too far. Yeah, our goal is to implement playback view control, and the question is, how many lines of code do we need? Any ideas? If you write some control like that, how many lines of code usually your file has? No guesses? Okay. 500. That's reasonable. Another? You could do it in Java in 18? Okay. Yeah, my implementation has 120, including white spaces. And I will show you all of them. But yeah, let's not focus too much about understanding every line. The idea is to show you how it looks like, how it feels, not to understand everything. Of course, we need to start with a boilerplate. So we implement just playback view, which extends relative layout. And in here, we have used this view helper. This is like interface, we just use another, this is multiple inheritance in Scala. This view helper that we have provides all the magic. It implements our event context, because we need event context everywhere we subscribe to something. And it has some implicit methods like the inject one, where we inject the service, or the inflate. Or there are some implicits which allow me to write binding for views this way. I just create a variable with the type text view and assign ID from our Java. View helper takes care of that, of calling find view by ID. Yeah, we will start by implementing displaying of current state, which means display the playback state and current song information. And to do that, we will define some helper signals. First one will be current song information, because our service only provides us with current song ID signal, and then there's method to get information for a song. So we can compose them in flatmap, and we get current song, which contains a song object, not just an ID. Then we can get the current album signal, which uses current song and composes it with method to return information about an album that this song belongs to. And signal to get our current playback position is just current song composed with playback position method. This current position is a signal which contains millisecond value of current playback position. We will use that later. Let's start with just a label for a song. In this case, we need to know what's the index of currently played song and how many songs there is in an album. So we actually combine two information in here and use it as a string. So to do that, we get our signals that we had before. We get current song, we get an album. We could use current album actually there. And generate a label string from there. It uses the index of the song in an album. That should be pretty straightforward. And then we subscribe to this new signal and just call set text there. We make sure that this is done on UI thread. So before, whenever we processed this label, when we generated the string, we didn't really care what thread it is running on. Only here we just make sure that this runs on UI. Okay, we have a label. We can move on to current song duration. This will be easy. We'll just take current song, take duration out of it, convert it into string, and then make sure that on UI thread we just call set text on proper label. Current position is a bit more tricky because, like I said, we only have position in milliseconds, and that means depending on the playback service implementation, this could be updated many times a second. Like in my case, this would be like even 100 times a second. We don't want to update UI 100 times of every second. So we can use the property of our signals, which is whenever there is some value change, but at some point in our graph, this value actually doesn't really change. But there was a change, but the value stays the same, then we stop processing it. So we just define position seconds, which takes current position in milliseconds and converts it to a seconds. This signal will only fire whenever the second changes. So we will get UI updates at most once a second. And once we have the signal, we just convert it to a string and call set text on a text view. The same way we can handle progress bar. For progress bar, we also need some duration because we need to compute the value from 0 to 10,000 because progress bar takes the values like that. So we take current song, position in seconds, and compute the value for the progress bar. And of course, we bind this signal to set progress method on the progress bar. Now we can move on to implementing buttons. There are three things that we need to implement. First is that some buttons need to be disabled. In this case, this is the previous song and next song button. If there is no previous song, then the button should be disabled. The same with the next one. If we are on the last song in an album, then the next song doesn't work. Then play button also handles two states. It has a play and pause, and we need to change the icon depending from the current state. And of course, we need to execute some actions when user clicks on the button. We'll start by disabling the buttons. For that, we'll again create some intermediate signal. In this case, this will be indexed in an album. It takes current album, current song, and computes a pair, which is an album and index in this album. This way we can easily get current song index in an album. And we will use it to define another signal, which is previous song signal. Previous song signal takes this index in an album and checks if the index is 0, then the previous song will be empty. If the index is not 0, then we can take the previous song from an album and returns it. So this previous song signal has an option with song inside. The same with next song. If there is next song, then there will be something. If not, there will be none. And then we can just use it. We first map it to isDefined. isDefined checks if the song is there, because there was an option. So whenever the song is there in a signal, there we call setEnabled true. If it's not there, then we call setEnabled false. We have disabling. We can handle the icon for a play button. That's pretty obvious. We just take a signal for playback state. If the state is playing, then we will use pause icon. If the state was not playing, then we use play icon and bind this icon to set image resource on the button. To execute actual commands whenever user clicks on it, we can use current value from a signal. With this approach, I don't use any specific convert button into event stream and do something like combining stream like you would do in RxJava. I just register a regular on-click listener and I check current value from a signal that has this value and just call a method on our service. Like in this case, I check what's the current state of playback, if we are playing or not. If we are playing, then I will call pause method. If we were not playing, then I will call play with an ID of current song. The same for all other buttons. Whenever I click on rewind, then I check current position, subtract 30 seconds from it, and call play on that. Well, not play, just seek. And the same with forward, and previous we'll use our previous song signal. So we just check what's the current value of previous song and call play on that. In here we use this for each and flatten. This is because signal could be empty, and when the signal is empty, then this line will actually do nothing. It will check if it's empty, I'm not calling play. Most of the time this on-click listener will not be called because we handle disabling of a button. But if in any weird case it's actually called, it will not crash, it will silently do nothing. The last thing that remains is handling input on progress bar. We could handle that by callbacks on progress bar, but this is not great. I don't really like how the progress bar works with swiping, and also it's close to buttons, so it's kind of risky. So let's implement horizontal swipe gesture on the whole view. Actually, handling touch input in reactive way is a topic for completely another talk, or maybe a series of talks. So I will use my helpers to the header. Touch reactor is my helper which just implements on touch listener and gives me event streams with these events that I got from listener. Then I have a set of gesture classes, like this is track gesture. It will give me only callbacks when user is actually dragging on the screen. These gesture classes have some nice properties that we can compose them. We can have several gestures on the same touch reactor, and they mostly work. But yeah, that's another ugly topic, but we can use it in here. So we will define some signals again. Like this one is swipe distance. Given some start position, this will create a signal which will always give us swipe distance from the start position and only in x-axis. when user starts swiping, then it will be empty. Or actually, in this case, it will be always 0. But when user is swiping, there will be some distance from the starting position. The same we just have a function to get current duration. It just goes to the current duration signal, takes the value, converts it to milliseconds, and makes sure that there is 0 if current song is not selected or stuff like that. Yeah, those are our helpers. And this is implementation of swipe gesture. We won't go through it. I will just tell you that it handles actually two things. It's not perfect because it does two things at once. First is it invokes a seek method whenever user stops swiping. And it also gives us information about current position of a song when user is swiping. So it is a type of signal has a value option of milliseconds. So it will be empty if user is not swiping, and it will be some millisecond when user is swiping. And this millisecond is the position of the song that we are swiping through. It uses these helper signals that we had before. And yeah, so this was handling our calling a seek method. Whenever we swipe somewhere, we lift the finger, then the seek method is called, and playback goes to somewhere else. But we also want to update UI whenever user is swiping. Like we want to move the progress bar to the position where you would end up when you lift the finger. And we want to update the label. So we'll see exactly in seconds where you will end up when you lift the finger now. Before we had this position seconds signal, and we just bound it to set text. So we actually only need to re-implement position seconds signal, taking into account swipe position. So we will just take a swipe position, check if there is some position of none or none. If it was none, so user was not swiping, so we use this position that we had before. And if user is swiping, then we will use position from the swipe position signal. And we only need to re-implement this position signal, replace it with this one, and UI will automatically work, because this signal was used to update text view and the progress bar at the same time. Yeah, we can try to run the demo. I have an emulator here with this app installed. This view contains exactly the code that I was showing to you. And yeah, we have our player, and we can try to play. We can move, we can change songs, and we can also rotate our view. This is actually regular life cycle of Android, so this is actually killing the app, well, not the app, the UI. And we didn't need to handle any state. We didn't need to save the state of the UI. Signals that do this for us. Oh, right, and we can also swipe anywhere. Maybe you just noticed there was minus. Yeah. So our swipe position signal could go into minus because I didn't handle that, but seek method handles that gracefully, so it's not a problem. Not a big problem at least. Okay, so this is the player. Yeah, you can find the code for this demo application on GitHub. There is the full project with everything in Scala. There is a SBT build setup, so you can just run it on your device, run it on emulator if you want. You can find that in dependencies you will find libraries those are my utils libraries which contain signals implementation and some other utils that I use. Maybe at some point the signals will become proper open source library. Right now it's just my utils library. It's open source, it's on GitHub, so you can find it. You can check the dependencies of this project. Yeah, just some final thoughts. Maybe you noticed that every time we implemented something, there was this common pattern. We had to define some signal and then bind this signal to some method on the view, on some control. And this is how I create reactive applications. Basically, every control in UI has a corresponding signal. This is the same for some composed custom views. Whenever you have like song details view, then this view will be bound to a signal with current song or currently edited song, and inside it will convert the signal into specific signals for specific fields like name or stuff like that. This also means that you can move these signals to some other places. Have some external, some service or some controller which doesn't really care about UI per se. It doesn't have any references to UI code. This means you can run headless application without any UI and basically test all the UI logic, because the idea is that view, some control on UI, just displays the value of a signal. So you can assert the values of a signal. And you can also change them, so you can basically run your application without UI and test everything there. One question that I get from time to time is, why not RxJava? Well, first thing is that I wasn't really aware about RxJava when I started working on that. It was like 3 years ago. But it's actually good because RxJava has some specific properties that I don't really like, and if I knew about them, maybe I would write signals differently. Like RxJava, at first, is that the API is cumbersome. Second is that it cares about too many things. Like RxJava has error handling inside. It's like exception handling, and we don't really like exceptions in Scala. And in this way, we also don't like. I don't like error handling in RxJava. Because error could be handled as a different type. When you expect some error, then you use option or either inside of a signal. And you don't need to care about it in all other places. And also RxJava has a completion, and the event stream could complete. In signals, there is no such way. Once you create a signal, it has a value. It may change, it may never change, it will never complete. This is very much more limited than event streams, but it's better suited for UI, in my opinion. I actually developed not only UI using this, and it works. Some other questions?
Hi. Could you present some details about current Scala state on Android, any dependencies, requirements, how practical it is now on Android, and what are expectations for nearest years, Scala and Android? Thanks.
Yeah, that's the typical question I get, and that's why I said at the beginning I won't show you how. Yeah, actually it works, and it works almost from the beginning. The only problem that you have at first is tools and setting up your build process to work quite faster than usual. You need to use Procar to strip the libraries because the Scala library itself is big. And this step is usually slow. So what I do, I have preloaded Scala libraries on my phone. And then during development, I don't include these libraries in my project. So my build times are even faster than Java builds in corresponding application. Scala in itself, build is a bit slower, but incremental builds are fine. And usually in Android, build compilation is not the biggest issue. Other stuff takes longer. Some people think that Scala is slower. Scala can be slower, but in general, you can write it the same way like you would write in Java, and it will be exactly the same speed. When you do a lot of stuff functional way with collections, it may be slower, but it's just constant slower and you don't really care. In UI, you care to be reactive, to react to changes and show the spinner whenever there's some background work. But user doesn't really care if the background work takes 100 milliseconds or even 500 milliseconds most of the time. And if you have really performance demanding tasks, then you go to native Go or render script. Like in Wire, we display GIF, animated GIFs, and the coding is done in render script. For me, Scala works great. Yes.
It unfortunately also goes in the direction of Scala for Android. Can you mix RxJava and Scala application that you, for example, can use your Scala implementation for UI, which I think is a very good thing, but still have RxJava together with, I don't know, retrofit and so on. So can you actually combine those tools?
Yes, it's just a library. It doesn't have any conflicting dependencies. You can use both of them. There is right now no conversion between RxJava streams to signals and stuff like that. You can also add it. I actually have my own event streams, which are based on the same idea that Signal have, like this laziness when I disconnect and control the state of components. So I don't need RxJava because I already have my own events. But yeah, like you say, you want to use some library which depends on it, you can.
So I could use, I mean, how do you do the network communication then? Is this already available in Scala?
Most of it, yes. Actually, what we use is, the project is called Android Async. I don't know if you've seen it. It's the async client, it's on GitHub. That's what I use because I like the async part. I started doing this on Nexus 1, which doesn't really like concurrent connections. It was slowing down with just 4 concurrent connections. So I was always limiting the number of threads. That's why I always go for async stuff. And then I built some small wrappers in Scala around it because it's very easy with Scala.
Hi, I have one question. You one slide there was with view helper, and you mentioned something about multiple inheritance. Is that something like in C++ or?
It's kind of similar. This is those are Scala traits, so you can mix in several traits. Trait is like in Java 8 you have interface with implementation. So trait is something like that, but a bit more powerful.
So basically, your class had all the methods from view helper
exactly.
Already implemented.
Exactly.
Default implementations in Java 8, right?
Yes, something like that. It's just much more powerful. And I have several helpers for different things, like for fragment and activity, which have the same specific logic for specific contexts.
Okay, thank you.
Thank you for the microphone, also for the talk. I have a question. You said you bind all the signals to the views, and you don't have to do any manual like binding or cleanup at the end. It's all tied to the, let's say, activity or fragment lifecycle.
Exactly.
Imagine you have a lot of views, you have a lot of signals in parallel tied to one screen. At which point does this get like a large overhead? At which point do you update the UI too often because of different views being updated? Like, what's the scalability of this for now?
I haven't run into any problems with that. The main part is that you actually run it on UI thread, and this threading UI, this is special execution context that I have, and it takes care of batching. So like you have many updates at the same time, they get queued on this execution context, and they are executed on a UI thread at the same time. So actually, whenever my execution context gets hold of UI thread, it executes all pending operations. So this kind of batching works pretty nicely.
Nice.
Thanks for the talk. It already looks like pretty similar to RxJava, especially a bit close to Android even.
like handling lifecycle, for example. Do you plan to provide Android widget bindings like RX bindings from Jaguar? Because it's like a logical next step to have, because now you have this border between business logic, which is in a signal format, and you still have this native events. Probably you would like to have that form of signals as well.
That's actually a good idea, and you could do it. I'm not planning to do it myself right now because the way it works is fine for me. Yeah, it's a bit repetitive because every time you add this threading UI, you have the block, but it's also much more powerful right now. And I don't need to create this specific implementation for all the view to bind some specific thing. So it was much easier for me, but yeah, maybe at some point whenever this becomes a proper library, it could be useful.
How big is your APK after programming?
Well, that depends from the settings. The demo application that I showed you right now is 5 megabytes, but the setup for programming is not really very specific. It excludes a lot of stuff because I didn't want to care about it. Program often would fail. I would think that with this application I could go down to around 1.5 megabyte, maybe a bit less. Because in my application where I use the same setup, I use Scala and a lot of stuff, at the beginning it was 1.5 megabytes. Later I added stuff and now I'm closer to 5, but there is a lot of other stuff. With current Android applications, the APK size is not really different because Scala library is big, but like guys before said, once you include all the Java libraries, once you include Guava and stuff, you get very close to that. Okay.
So you're talking to the wrong guy. Every kilobyte counts for him, but for the rest of us, yeah. The APK limit is 100 megabytes now. So.
Yes, but
Are there any other questions?
I've seen that inject word. What's that? Is that like a custom DI framework or it's built in Scala?
Inject is just my own implementation of independence injection. It's very, very simple. It's just one class which has a registry of classes. Then you can do a lot of implicits. Like implicit is just a parameter that will be added by a compiler, so we don't need to see it. That's how I handle this UI, even context. Whenever I subscribe, I don't really specify it there, and it already knows that it's inside of context and knows how to destroy stuff. You can do dependency injection the same way. I just chose to use registry because then I can have scoped singletons, like singletons for service. And it's just one class, it's easier than adding a library.
So, thanks for the talk. I have a question about the media player, because you showed orientation change, right? And you kept the playing position and also, I guess, the instance of the media player.
Yes. This is done in service.
So this is a service which you use, right? You're just binding the UI to the service, or is it like an event bus, or how can I imagine?
This uses the storage. This is another idea I could give another talk. I use the storage classes, which basically the database handling with all the caching in there, and every change in the storage has a signal, so we can register a signal on a storage. So my playback, my media player runs in a service, has access to storage, and actually updates playback position for every song every time it changes. But because the storage does caching, so it's not a problem, and every time this thing changes, the storage actually generates a signal. And if when UI is created, it registers a signal on the storage and listens to changes there.
So you have constant I/O for updating the UI.
Yeah, minus the caching. Like in this place, I have storage has 1 second caching. Whenever position changes, then I have it in memory only and update my database once a second. For playback, you can solve it differently. You can keep it in memory and only save it when application ends or something like that. But this is completely separate logic in a storage.
and like having a memory leak by leaking the activity, by having not unsubscribed or however?
Well, Signals handle that for you. Whenever the application is paused, then this view helper actually unregisters everything. So there are no memory leaks in Signals itself, but if you leak memory somewhere else, then yeah, of course.
Okay, so we are running out of time. If you have any other questions, I'm sure you're around. We will continue at 4 p.m. with a talk on unit testing. Maybe you want to ask him questions about testing in the break. So give him a big applause for the talk.